So let's talk about that medullary cavity. So medullary cavity, what's in it? I mean, like something's in it, but what's in it? Well, this is where we find our bone marrow. So our bone marrow, this is a real cool picture. I think it's from OpenStax, but I love this because I think this is the head of a femur. And what they did is this cool kind of like cross section of this. I haven't seen a bigger picture, but yeah. What you see is the outer surface of this bone, pretty dense right here, but you have this red marrow, and then you have this yellow marrow in the very center. So there are two main colors to bone marrow, red marrow and yellow marrow. And hey, speaking of yellow marrow, what tissue and what's connective tissue did we talk about earlier in the semester that's kind of off whitish and yellow? Hmm, maybe adipose tissue, right? Especially white adipose. So yellow marrow, that's a big hint to what yellow marrow is. Yellow marrow is yellow because it has a lot of this, what is fatty tissue. So that's what the yellow marrow pretty much is. And if you ever had like this very decadent Italian dish called ossobuco, where they basically, or it's like all the fatty stuff inside of the bone is all the marrow, the yellow marrow, and it's a very like don't eat it if you're watching your cholesterol intake, but yeah, it's very fatty rich because of that yellow marrow. Or if you're like a ramen fanatic like me, if you ever had that tonkotsu ramen, if you notice that some ramen, that type of ramen has all these like little fat droplets, well, it's also like tonkotsu refers to pig bones, and it's taking the flavor from the bones, but also the marrow inside the bones and all the fat in it. That's why it's also super rich and also super bad for your cholesterol as well. But it's so delicious, it's kind of worth it every so often. And if you, I think, was it, is this, so I think it was on Planet Earth or one of the David Attenborough thing. I think this is a bird in Africa. I think it's called a bearded vulture. I can just imagine like David Attenborough like, the bearded vulture is native to Africa. And what it does is drop these bones from high elevations. So the cool thing about these vultures is like, I like how, as you can tell, I love birds. But the thing is that they're predators, they're scavengers, and what they do is take these bones from freshly dead animals, they take it to great heights and they drop it, and so that these bones break open. And what do they eat? They want to eat that yummy, yummy, fatty marrow inside because it's full of calories. And oh, I don't know how picky they are with flavor. But I imagine for them it's pretty darn tasty. So this is what yellow marrow is. Again, yellow marrow is very fatty, and for people who like to eat marrow, or creatures who like to eat marrow, this is why it's very rich. Now, we talked about yellow marrow. What about red marrow? So red marrow is red for a reason. So where do you find red marrow? Well, you find them in flat bones, spongy ends of long bones, like we saw with the femur over there. And then why it's important is that they're the source of hematopoietic stem cells. Now, these are stem cells, but whenever you actually see that root word heme or hema, H-E-M-A or H-E-M-E, that refers to blood. So these are stem cells that generate pretty much every cell you can find in your blood. So what the cells of your blood are called are formed elements. And remember, blood is a connective tissue, but a special one. It's a fluid connective tissue. So connective tissues have their matrix, and the matrix of blood is plasma. But the cells, the specialized cells, there are three main categories: red blood cells, white blood cells, and platelets. So this is where when you're starting out, I remember like red marrow makes red blood cells, but not just red blood cells. It actually can make all blood cells. So don't worry about this figure in this semester because we cover this more in detail next semester with PHYL 142. But yeah, these are the hemocytoblasts is another name for these hematopoietic stem cells. And remember, two things with stem cells. They can regenerate, so you can create more hematopoietic stem cells, can generate more hematopoietic stem cells. But not only can they regenerate and renew, they can differentiate. So they can become different types of cells. And depending on it's kind of like whether you want to become a business major or a science major, you kind of go down these paths that lead you to different careers. Same with hematopoietic stem cells. They can become a myeloid or a lymphoid stem cell, which can become all these other types of cells. Again, this is not something I expect you to know at this point, but basically, all of these cells very down here at the very end of it, these are mature blood cells, and all of these mature blood cells can trace themselves to an original hematopoietic stem cell. So again, these are why these are very important, especially in bone marrow transplants, because if someone doesn't have, like, the thing is, like, say someone has leukemia, a common thing they do with leukemia is chemotherapy or radiation therapy or a combination of that. Sometimes that obliterates their hematopoietic stem cell population. So how do they get their blood cells back? Well, maybe they need a transplant from somebody else's hematopoietic stem cells so that they can regenerate all of these cells you are supposed to have in your blood. So this is why bone marrow is super important. Alright, so the interesting thing about red marrow is that it's converted to yellow marrow with age. So you start off with a lot of red marrow when you're born, but eventually it starts to yellow and accumulate the triglycerides and fats. So you don't have red marrow, the same amount of red marrow as you did as a kid, or when you're like 10, 20 years from now, you're not going to have the same amount of red marrow. So this is what it looks like when you're born. Notice that this long bone, this femur right here, is full of red marrow. But what happens over time is that this red marrow starts to convert into yellow marrow, and as it starts to get, so as you get older and older, so you might be around this age. So yellow marrow around 10 to 20 years, you see that more and more yellow marrow builds up. And then eventually, when you're adult, 20 plus years, is that compared to all this red marrow that could develop into blood cells, you only have a little pocket left at least in the femur. So this is why, I remember like when I was helping out with the local bone marrow drives to help find matches, and there's somebody asked about bone marrow transplant. Normally, parents to child. The thing is that with this is like your tissues actually have unique IDs. They're called human leukocyte antigens, HLAs, and they involve these proteins called MHC1 and class 1 and class 2 receptors. So basically your cells, every cell in your body has this kind of like unique ID. Now the thing is that this is how your immune system is able to, one of the many ways your immune system is able to tell your cells, compare it to some sort of foreign pathogen or bacteria or other cell that happens to find its way inside your body. Now this is tricky because everyone pretty much has, well, maybe except for identical twins, have different HLA types because we have different sets of these different types of proteins that kind of serve as an ID for our immune system. So this is why typically if they try to find someone in the family or someone from a similar genetic background. So because often that some of these ID numbers or these like proteins, they're more common in certain populations as humans developed throughout the world. So this is why whenever you see, especially people who live here in Hawaii, that they're saying whenever they are trying to find a bone marrow transplant recipient, why they're always trying to say like, oh, that's why they always say what background they are. Like they say that, oh, they're Japanese, Chinese, Hawaiian, Portuguese, Ethiopian. And the thing is that the person is probably going to have all these proteins from different areas of the world that develop. So the thing is that if anything is different to the immune system is more likely to attack it. So if you transplant something into somebody at random, they're going to recognize, hey, all these surface proteins are different. I don't recognize this. I'm going to attack it. So that's what we call graft versus host disease. That's why it's very important to have that and it's not just for bone marrow transplants. That's why with organ transplants, you're more likely to find it from someone related to you because higher chance they have similar proteins on the surface of their cells compared to somebody random. That's why when I was helping out on one of these drives, somebody was very upset. They're like, why can't I donate, or why do I have to be under 45? Well, this is the exact reason why. Because if we're trying to transplant this red marrow material, the less red marrow you have, I mean, is there going to be, how much do we have to actually work with? You actually have to, well, they actually have other ways of getting these hematopoietic stem cells or pluripotent stem cells that help to make bone cells. But the old way is that you actually have to go into the bone itself. And if there's not much red marrow to go to begin with, it's going to be very difficult to get. So this is why The younger you are, the better candidate you are in saving someone's life via bone marrow transplant.